All right, it looks like we are live. Hey everyone, long time no see. It's been about 2, almost 3 months since I've done a live stream. Just a lot of personal things have gone on in my life and my business as well. But the main factor I've had that has prevented me from doing any live streams was I had my wisdom teeth removed. So I have 3 giant holes in the back of my mouth, and it's been probably about 3 weeks since I've had them removed, and it's just been difficult to talk, you could say. I actually still don't have feeling in part of my face right here, but it's slowly coming back. Wisdom teeth were supposed to be removed about 10 years ago, but prior things had taken place that prevented me from actually getting them removed. With that being said, I have actually been not as involved with doing live streams, board repairs in general. Instead, I've just really been focusing on growing my business, helping my employees succeed as well, and very happy where we're at right now. I think I can finally get back to focusing on board level repairs, and I figured this one was a really good one to go ahead and start off on. So, kind of like the title of what this YouTube video says, we have a MacBook here that was actually mailed in to us from a customer who found us on YouTube, and this one specifically just will not turn on. It actually has a very interesting issue, and I have a gut feeling what's going on. I think we're experiencing a quarter fan spin issue. Just to kind of show you, I'm going to go ahead and turn on my power supply software, and we'll see how much power or amperage the computer is actually taking. So we can see in the top left with our software we have here, it's pulsing. We're getting 0.02 to 0.2 to 0.8. So the computer is actually turning on now, but it's intermittent. It's never consistent. And the only history we really have with this computer is the client himself had replaced the battery. Now, usually what's going on here from my experience is the current sensor circuit around the ISL, the charging circuit, which eventually creates a PPBUS, could potentially be damaged. And that can happen if you've ever used an aftermarket charger, or in some cases, a battery can actually kill it. So what we're going to end up doing is pulling the logic board out and just kind of measuring the resistors around, the current sense resistors around our ISL, and see if that's going to be the reason why it's not turning on. So I'm going to hook this back up and let's see what we're consuming. So 0.02, 0.01, 0.02. So we can see a second ago it turned on, but it's not turning on anymore. Let's see if we can get it to do a quarter fan spin again. So it turned there for a second and then stop. So let's go ahead and just start pulling the logic board out and inspect the current sense around ISL. And the RAM's also been upgraded in this model as well. Looks like they put 16 gigs of memory in here. That's the highest this one can go to, but if you can take advantage of it, I would recommend doing that on one of these older unibodies. This one specifically is a 2011 model. The 2011s, they go to macOS High Sierra 10.13. High Sierra is technically no longer supported by Apple. However, we still have a lot of clients that still come in with these specific computers, because High Sierra does seem to still be supported by certain app developers. A lot of DJs actually come in with these unibodies still. And the main reason why is because you can replace the super drive, the fancy way of just saying the CD drive, with a secondary hard drive. So one thing that people like to do is they'll remove the mechanical drive that originally comes with the computer and upgrades it to a solid state drive. Then they'll take the super drive and get a special caddy. You can get a caddy off Amazon for about $10, and put in a larger 2 terabyte mechanical drive. So that way you have the benefits of almost like a fusion drive, but you have the benefits of a solid state with the operating system and your programs, and then you can use the mechanical drive for storing videos if you're doing any video editing, or music if you're a DJ. I personally used to have that set up on my 15-inch 2011, and what I would do is I had Time Machine set up using the hard drive caddy. And so the benefit with that is my computer was constantly backing up without having to be tethered to an external mechanical drive. Tim says, hey, there he is. Nice to see you. Yeah, it's been a very long time since I've done a stream. My voice is actually a little shaky just because I haven't really had to talk to people while I do board repairs, so I do apologize if I kind of rant about random things. But no, the last couple of weeks have just been difficult. Eating has been a pain, a challenge in itself. I have lost probably about 5 pounds just because after I had my wisdom teeth removed, I went strictly on a soup and yogurt diet. I thought I'd have the smart idea, though, that the day I had my wisdom teeth removed, I actually came straight to work. And I didn't tell my oral surgeon about it, but my employees were actually kind of shocked that I showed up. And everything was fine for the first day. That was the only day that was fine. I was able to get some work done. I had giant cotton balls in my mouth, so I couldn't talk. I had a little bit of hydrocodone just to help with the pain. And the following day is when all hell broke loose. So I really should have stayed at home and kind of rest up, but I just love doing what I do, and I guess I couldn't stay away from being here. All right, so now that we have our logic board out, let's go ahead and set everything to the side. We'll leave our fan out just because we'll need that for checking, showing our quarter spins. So the first thing I notice on this board, it's really dusty. And I'd say that's pretty typical for a computer that's about 10 years old. We'll give it a good dusting afterwards, just to blow everything off. To the naked eye, I don't see any signs of liquid damage. So I'm thinking in this case, potentially because of the third-party battery, or maybe an aftermarket charger, it's possible that the ISL current sense has been messed up. Now, it's actually been a while since I've done that and done this specific repair on a unibody. So I need to see, pulling up our schematics here, where that is located. I'm going to have to put on my glasses because I have actually updated my system here too, so I have a much smaller monitor than I used to. So what I'm going to look for, I'm just going to do a search here for ISL. It looks like that is U7000. So U7000 is actually on the top layer of the board. So technically we didn't even have to pull the logic board out in this case. I just wanted to pull it out anyways just to make sure there was no signs of liquid damage. So let's take a zoom here on U7000 and compare it to our schematics here using Flexboard View by Paul Daniels. So we can see here it's our battery charger, and the battery has been replaced. Specifically, it's an ISL6258. I feel like that's not right. I think that's actually a typo. If that needs to be replaced, I'll look a little further into that. So here is what our battery charger, which eventually creates our PPBUS, looks like. So to try to not overwhelm anyone, this is where power from the charger or the MagSafe charger comes into the computer, goes through an inrush limiter, which prevents power from going back up into the charger and causing the charger to explode. And then U7000 is going to break down the power that eventually creates PPBUS, as well as charger battery. So we can see here at the end, it says to system PPBUS G3 hot, but underneath that we also have a to and from battery. So that way, if the battery is below a certain percentage, it will start charging, if I say that correctly. It will actually send power to the battery to charge it, and the battery will send power to PPBUS whenever there isn't a MagSafe charger connected. So on U7000, what we want to look at is going to be the parts that say CS. Now CS is an abbreviation for current sense. We have current sense, I'm assuming this is current sense out positive, current sense out negative, and over here on pin 28 and 27, we have current sense in positive and current sense in negative. So if we look at pin 28, what it's going to do is it's going to travel through this line where there's a capacitor right here, but there's a resistor, it's R7021, which is only 10 ohms. From this resistor, it's going to go through charger CSI, current sense in, R positive, and then we have another resistor. I believe this is a shunt resistor, which is very, very nominal resistance. It's 0.02. It then is going to come out of pin 4 on this resistor, go back through R7022 through another 10 ohm resistor. Now, the reason I'm pointing out these specific ohms is because they add up together, simple addition. So we have 10 plus 0.02 plus 10 is going to give us a resistance of roughly 20.02. So this is going to come back into charger current sense in negative. So between pin 28 and pin 27, we should have a resistance about 20 ohms roughly. Let's go ahead and check that and see what we have. So pin 28 and 27, I'm going to change this orientation to match of what my board looks like on my desk. So pin 27 and 28 going to be right here on the bottom left. And we can see we have our resistor or capacitor, the C7020, that we can actually measure in ohms on both sides and see what we get. So let's go ahead and switch over to our microscope camera and check that out. So here is our ISL, and let's get this in focus. And let's make sure that it's focused over here. It looks much clearer than I have done in previous streams. And we can see our capacitor right here, C7020. And what we're going to do is just kind of measure either on the capacitor on the two test points. So let's go ahead and put our multimeter into ohms and measure and see what we get. Now we're looking for about 20. And that's exactly what we're getting. 20.1. So that's exactly what we want. So there's two parts of the current sense around ISL. And the other part that we want to check is going to be around the battery area. So we can see right here, pin 18 and pin 17. Current sense out, positive and negative. Now if we look at pin 18, we have another capacitor very similar to C7020. This one is C7050. And when it goes through here, eventually makes its way to R7051, which has a resistance of 2.2 ohms. Then it has another shunt resistor, very similar to what we saw on the other side of the ISL, that is also very nominal, 0.01. So it comes out of this shunt resistor through pin 4, back up into a 0 ohm resistor. So we add 2.2 to 0.01 to 0, which is going to give us something between 2 to 3 ohms, very, very small. So let's go ahead and check exactly where pin 18 is on our U7000. So back over here onto the flex board view, pin 17 and 18 are going to be near the top. Here is our capacitor, C7050. So let's measure that on ohms and see what we get. Change back over to the microscope camera. And I think I lost my place. I did. Where'd we go? Ah, there we are. And there's actually two test points as well up here and near the capacitor. So we want to get a measurement of about 2 to 3. And instead we're getting 17. So we have an issue here. So basically what's going on is the computer, this would explain why it sometimes works and sometimes doesn't, because usually the other current sensor I discover is the issue here. But this one near the battery circuit is really what's going on, which could be attributed to the aftermarket battery that's installed. So being that we have a resistance of about 17 ohms, basically the U7000, it's doing its job and cutting off the computer. It feels like that it's sensing too much current and just shutting itself off. So what we're going to need to do is just go ahead and basically replace these three resistors because something is resisting too much. So we're going to replace R7051 and R7052 as well as the shunt resistor. We can even see it's critical right here for the battery for R7050. And let's see exactly where the shunt resistor is hiding. It's right above Q7055, which is going to be what's responsible for sending power back and forth between PPBUS and the battery. Let's go ahead and start working on that. All right, so that would be the shunt resistor right there. And we're getting a proper reading of 0.1 ohms. So what about the other resistors? I think it was R7021 and 22. And that's our audio chip. That's not what we want. It's a little hard to see, but it kind of looks like there's something going on anyway with that specific resistor. Which one is that? That is R7052, not 22. R7052 looks a little suspicious. And it's underneath some underfill, so I'm going to use a low temp, about 150, and my scalpel to scrape that off. And just because I don't want to smell burning mask, I'm going to go ahead and turn on my fume extractor. I've noticed you've uploaded a lot more videos lately, Tim. I've tried to peep in on them from time to time. They look really good quality. Aha! I think you can see our issue. Let's see if I can zoom in a little bit more. That resistor does not look good. Let's measure and see what the impedance is on that specific resistor and see if it's resisting. We're getting 14 ohms across that resistor. Now, what is that resistor supposed to be again? That one is supposed to be 0. So I'm going to go ahead and remove that using my micro tweezers. Pardon me. Sorry, had to sneeze. Okay. And we're going to need a donor board for this one. Now this one here we have is a 2012, however I believe that it uses the exact same current sense. So let's check out this resistor and see what the resistance is. We're looking for about 0. That's what we're getting. So let's borrow this one. Tim says, yeah, I've been trying, kind of slow repair-wise right now. I have a theory everyone's on vacation. Now that everyone's starting to get vaccinated and the world is starting to return a little bit semi-normal, and the fact that people couldn't vacation last year, I think everyone is in Florida. I think that's what it is. I say that because most of my clients, they need their devices fixed within a day or two because they're taking it out of town, particularly iPads, because their children need something to entertain them on long 6-7 hour drives. I don't blame them. My parents used to have a custom van that had a VCR in it. We used to play Super Smash Bros. While we went to like Myrtle Beach and Charleston. But that's my theory, is the repair industry is slow, you could say, because everyone's gone. I have some Windows laptops I'm trying to learn on how to repair. That's impressive. I know there are some that are worth fixing, and I know that there's a lot that aren't worth fixing. For instance, like I think it's the HP Stream. It's like a $300 computer. Hands are a little shaky tonight. That looks good. Now, just to make it look better, let's clean it up with some isopropyl alcohol. Okay. Now let's measure the impedance of pins 17 and 18 on U7000. Excuse me. Now remember, that was this capacitor right here. I think that was C7050, and what we're looking for is about 2 to 3 ohms, and we're getting 3 ohms. This should be a successful repair. Let's go ahead and switch over to our overhead camera and see if we get a full fan spin every single time. I tend to avoid chrome devices. I know that if you're doing them in bulk, there is a market for it. I know someone in the Rossman Discord who has contracts with schools, so he's usually fixing a couple hundred at a time, and that seems to be where most of his revenue generates from. But doing 1 or 2 at a time, for me, it's not for me personally. Alright, so let's connect this and see. We have an instant fan spin, and we can see that we're pulling 0.8, which is booting amperage. I don't have my RAM installed, so it's not going to boot up all the way. Let's go ahead and stick a piece of RAM in here. Because we were getting intermittent issues, let's see if it works every time now. So 0.8, so it is booting. 0.9. Stop. 0.8, 0.9, fan spin every single time. So this is a successful board repair. I'll reassemble it and clean it up and contact the client tomorrow. But in short, what happened here was that the current sense around the ISL may have just had an influx of power that tried to go back through that resistor, R7052, and it looks like the only thing that it burnt up was U7052. Now, U7052 has a resistance of 0 ohms. It practically is a fuse, and it's preventing itself from killing our U7000. And what could have killed this is going to be one or two things, if I had to speculate. It's either going to be there was an aftermarket charger involved, just because it is increasingly more difficult to find OEM MagSafe 1 chargers for unibody devices. That's something that I'm currently experiencing, because Apple doesn't really make them anymore. So a cheaper alternative is to find a compatible charger from Amazon for about $20. Well, those aren't properly regulated and can send too much power through the charging circuit and end up killing a couple components. In this case, it looks like that it killed one of the resistors that's responsible for current sense. On top of that, there is an aftermarket battery in here. Aftermarket batteries can also cause this issue, which if we look at the schematic, we can see very closely this line around Q7055 goes directly to the battery. Well, we're very, very close in proximity to R7052. So it's also possible that the battery that was installed had damaged the logic board. And I guess really one way that I'll discover is I will end up doing a quality control test with the client's battery, and if the computer decides to no longer turn on, it's a defective battery. So that's typically going to be 1 or 2 cases in this situation. So this was a pretty fun short stream. I'm excited to start doing them again now that I can properly talk, and I appreciate you guys bearing with me while I I guess focus more on my business, but also kind of take care of some personal things in my life. Hopefully I will start to regain feeling in my face within the next 3 to 6 months is what I was told. But yeah, I guess that's all. So thank you so much for joining me this evening, and I'll see you guys all in the next one. Bye.